Let's continue with another definition. The function f of x will have a vertical asymptote at x equals a if we have any of the following limits at x equals a. Limit x equals to a from left hand side, f of x equals to minus or plus infinity. Limit x equals to a from right hand side, f of x equals to minus or plus infinity, and the limit x equals to a, f of x equals to minus or plus infinity. And note that it only requires one of the above limits for a function to have a vertical asymptote at x equals a, okay? And using this definition, and we can see that the first examples had vertical asymptote at x equals 0, okay? Previous example had vertical asymptote at x equals 0. And let me give you another example about the asymptote. And evaluate each of the following limits. Limit x equals to 4 from right side, 3 over 4 minus x cubed, and the limit x equals to 4 from left hand side, 3 over 4 minus x parenthesis cube, and the limit x equals to 4, 3 over 4 minus x parenthesis cube. And let's start with the right hand limit, okay? And for this limit we have the x over 4 because of the right hand side limit, okay? And so that 4 minus x is less than 0, so 4 minus x cube will be less than 0. Also 4 minus x equals to 0 as x equals to 4. So we have a positive constant divided by an increasingly small negative number. The result will be an increasingly large negative number, okay? And so it looks like the right hand limit will be negative infinity, okay? So we can say it will go to negative infinity. And this is the right handed limit, and the left handed limit. So when x is less than 0, so 4 minus x is larger than 0, and after that 4 minus x cube is larger than 0. And we still have 4 minus x approach to 0 as x approach to 4. In this case, we have a positive constant divided by an increasingly small positive number. The result will be an increasingly large positive number, okay? And so it looks like the right hand limit, it looks like the left hand limit will be positive infinity, okay? So the normal limit will not exist, since the two-sided, two one-sided, maybe more true, two one-sided limits are not the same. And the official answer to this example then will be does not exist, but let me sketch it, and understand, and at the x equals to 4 there will be a vertical asymptote, and our functions from the 0 when it approaches to plus 4 from the left hand side, it goes to the plus infinity, and when you approaching from the plus infinity to the x equals to 4 from the right hand side, it will go to the minus infinity, and this is 4 value, and this is vertical asymptote, and this function is 3 over 4 minus x cube, And let me continue. With another question or another example. Evaluate the limit x approaches to 0 from right hand side, ln of x. First, notice that we can only evaluate the right-handed limit here, and we know that the domain of any logarithm is only the positive numbers, and so we can't even talk about the left-handed limit because that would necessitate the use of negative numbers, Likewise, since we can't deal with the left-handed limit, then we can't talk about the normal limit, But this limit is pretty simple to get from a quick sketch of the graph by the same idea. And this will be this is ln of x, and the from this we can see that the limit x approaches to 0 from right hand side, ln of x, as you see, it goes to minus infinity. Okay. And another example. Evaluate both of the following limits. Limit x approaches to pi over 2 from right hand side, tangent x, and the limit x approaches to pi over 2 from left hand side, tangent x. Okay. Okay, and I'll sketch some vertical asymptotes. This point is 2 pi, this point is, I'm sorry, minus 2 pi, this point is minus pi, this point is 0, this point is pi, this point is 2 pi. Okay, and this is x, and this is y. And as you see from this, it's easy to see that we have the following value, and let me write them. Limit x approaches to pi over 2 from right hand side, tangent of x, okay, and this point is pi over 2, okay, this point is pi over 2, and this is vertical asymptote, and when you approach to pi over 2 from right hand side, okay, you will see your limit will be minus infinity, okay, and when you approach at the same point from the left hand side, your tangent values will goes to plus infinity, as you see. Okay, so on this point the limit will not exist. Okay, and let me continue with the limits at infinity. Okay, part 1. And the previous section we saw limits that were infinity, and it's now time to take a look at limits at infinity, okay? By limits at infinity we mean one of the following two limits, which is that limit x equals to infinity f of x, limit x equals to minus infinity f of x. In other words, we are going to be looking at what happens to a function if we let x get very large in either the positive or negative sense. Also, as we'll soon see, these limits may also have infinity as a value. For many of the limits that we are going to be looking at, we will need the following facts. Let me write these facts. Fact 1. If R is a positive rational number, and C is any real number that limit x equals to infinity, okay, C over x to the power of r equals 0. And the second one, if r is a positive rational number, C is any real number, and x to the power of r is defined for x is larger than 0, then limit x equals to minus infinity C over x to the power of r equals to 0. Okay. The first part of this fact should make sense if you think about it, because we are requiring r is larger than 0. We know that x to the power of r will stay in the denominator, okay? Next, as we increase x, then x to the power of r will also increase. So we have a constant divided by an increasingly large number, and so the result will be increasingly small. That means in the limit we will get 0, okay? And the second part of the fact nearly identical, except we need to worry about x to the power of r being defined for negative x, okay? This condition is here to avoid cases such as r equals to 1 over 2, and if this r were allowed, then we would be taking the square root of negative numbers, which should be complex, and we want to avoid that at this level, okay? And note as well that the sign of C will not affect the answer. Regardless of the sign of C, we will still have a constant divided by a very large number, which will result in a very small number, and the larger x gets, the smaller the fraction gets. the sign of c will affect which direction the fraction approaches 0. Okay, that's only that. But the totally amount is still approach 0, of course. And let's start of the examples with one that lead us to a nice idea that we will use on regular basis about limits at infinity for polynomials. Okay, let me give them you. And evaluate each of the following limits. Part A, limit x equals to infinity 2 times x to the power of 4 minus x squared minus 8x. And part B, limit x equals to minus infinity, okay, 1 over 3 t to the power of 5 plus 2 t cube minus t squared plus 8. Okay. Solution. And the first part, our first thought here is probably to just plug infinity into the polynomial and evaluate each term to determine the value of the limit. It is pretty simple to see what each term will do in the limit, and so this seems like an obvious step, especially since we have been doing that for other limits in previous sections. So let's see what we get if we do that. As x equals to infinity, then x to a power can only get larger, and the coefficient on each term, the first and third, will only make the term even larger. So if we look at what each term is doing in the limit, we get the following. Limit x equals to infinity, okay, 2x to the 4 minus x squared minus 8x, okay, and it will be infinity minus infinity. Now we have got a small but easily fixed problem to deal with. We are probably tempted to say that the answer is 0 because we have an infinity minus an infinity, or maybe minus infinity, because we are subtracting two infinities of one infinity. Okay. However, in both cases we would be wrong. Okay, and this is one of those indeterminate forms. Okay, this is indeterminate form. And we first started seeing in a previous section, and the infinities just don't always behave as real numbers do when it comes to arithmetic. Okay, without more work, there is simply no way to know that what's the infinity minus infinity. Okay, and it will be, and so we really need to be careful with this kind of problem. To read a little more about this, see the types of infinity section in the extra chapter of your book. So we need a way to get around this problem, okay? And what we will do here is a factor the larger power of x out of the whole polynomial, okay? And I mean that, okay? Limit x equals to infinity 2x to the power of 4 minus x squared minus 8x, it equals to limit x equals to infinity, okay? And you will take the largest power of x out, okay, and it will be, okay, x to the power of 4 times 2 minus, okay, 1 over x squared, okay, and the minus 8 over x cubed, right? And after that, okay, if you are not sure, you agree with the factoring about, there is a chance you haven't really been asked to this kind of factoring prior to this, okay? And then we call that, to check, all you need to do is multiply the x to the power of 4, okay? And this is very easy to understand. And after that, you will see, okay, when you will see that this point will be, okay, 0, and this point will be 0, so it will be plus infinity, okay? And the another part, okay, and the b part, same thing you can say for that, and the minus infinity 1 over 3 t to the power of 5 plus 2 times t cubes minus t squared plus 8 it was, okay, and they get out the large power of 3, and you will be obtain limit, I'm sorry, I think that was t, right? And this part is t, and this part is t, right? T approaches to minus infinity, and the t to the power of 5, 1 over 3, I'm sorry, and the right. And after that, this part will be plus 2 over t square, and the minus 1 over 3 cube, and the plus 8 over t to the power of 5. And this part will goes to, okay, 0, 0, and 0, and the minus will be here, and the minus infinity, because the power of the single number of, I'm sorry, the odd power of the minus large numbers will be negative, okay, so it will be minus infinity.